Hello everyone, today we are going to do GFG problem of the day, and the problem name is nearest smaller tower. In this problem we have been given an array of size n, and each value of each indices represents the height of a tower, and for each tower we have to find the nearest possible tower that is shorter than it, and we can look on the left and on the right side, both sides. So the constraints are that we have, if we have two smaller towers at the same distance, then we can pick the smallest tower, and if we have two towers with the same height, then we have to choose the one with the smaller index. So let us understand with an example, like we have 1 3 2, and the indexes are 0 1 and 2. For 1, there is no element which is lesser than it on the left side, and as well as on the right side. So for 1 there will be, the answer will be -1. For 3, there is one element which is lesser than, in the left side there is one element which is lesser than 3 and its index is 0, and on the right side there is one element which is less than 2 and its index is 2. We have two indices but we have to choose one. What we can do is we can calculate the distance from the 3. So the how we can calculate the distance is, the index of 3 is 1 and the index of left side number is 0. 1 minus 0 is 1, so distance in the left side is 1. Okay, the distance from right side is 2 minus 1, that is 1. So the distance is same from 3 on the left side as well as on the right side. So we can apply the first condition. If two towers are at the same distance, pick the smallest tower. So we have to pick the smallest one. So the value at index 0 is 1, the value at index 2 is 2, so the minimum is 1 and its index is 0, so we can choose the 0 index. Now for 2, the index at which the value is lesser than 2 is 0, and there is no element on the right side, so -1, it means only one element exists, so we cannot apply this condition and we can put the element on the left side of the left side. So the answer is matching. Let us understand the another test case. We have 4 8 3 5 3 and indexes are 0 1 2 3 and 4. Now there is one constraint also, like we have to find the nearest possible tower. What I'm trying to say that for 5 there is two towers on the left side which is lesser than 5, but we have to choose the nearest. So the nearest one is this one, 3, because the distance between 5 and 3 is 1. 3 minus 2 is 1, but the distance between 5 and 4 is 3, because 3 minus 0 is 3. So what we can do is we will calculate the left mean for each array index and also the right mean for each array index. So for left mean will store for each index the nearest minimum element on its left side. So for 4 there is no element on its left side, so for 4 there will be -1 because there exists no element. For 8 we can say that we can see that there exists only one element which is lesser than 8 and its index is 0, so we put 0 here. For 3 there is no element on the left side, so for 3 the answer will be -1. For 5 there exist two elements, 3 and 2, but we will pick the nearest one. The nearest one is 3 and its index is 2. For 3 there is no element lesser than 3 on its left side, so for 3 the answer will be -1. We have calculated the left mean. Now we will calculate the right mean. The right mean will store for each index the index of the number which is lesser than the ith index. So now for 4 there are two elements on its right side which are lesser than 4, 3 and 3. But for this 3 the distance is 2 minus 0, 2, and for this 3 the distance is 4 minus 0, 4. We have to pick the minimum distance, nearest one. So we will pick this 3 and its index is 2. Now for this 8 the same scenario comes for this, and for there is 3 elements, but we will pick the nearest one is 3 and its index is 2. For this 3 there is no element which is lesser than 3 on the right side, so for this 3 the answer will be -1. For 5 there is only one element which is lesser than 5 and its index is 4. For this 3 there is no element, so the answer will be -1. Now calculate the answer for each element. Now for 4 there exists no element on the left side, but there exists one element on its right side, so we can put this element, there will be no comparison. For 8 there exists one element at 0 index on its left side and the another element on the right side and its index is 2. We have to pick the uh, pick 1. So from 1 the distance between 1 and 0 is 1, and from 1 the distance between 1 and 2 is 1. So the distance between these two elements from 1 is same. So if the distance is same, we have to pick the smallest tower. So if the distance is same, we have to pick the small. Let us see the size of height of the tower. So at 0 index the height is 4, at 2 index the height is 3. We have to pick the minimum, so the minimum is 3 and it is at index 2, so we will write 2. For 3 there exists no element on the left side and no element on the right side, so the answer for this will be -1. For 5 there exists one element on left side and another element in the right side, and its indexes are 2 and 4 respectively. So now for 5 there is also confusion. So what we can do is we can calculate the distance. For from 3 the distance between 3 and 2 is 1, and the distance between 4 and 3 is 1. So distances are same, we have to pick the smallest tower. Okay, so what we can do is the distance is same, so we have to pick the smallest tower. We can see that at index 2 the value is 3, at index 4 the value is 3. So we have the same height, so in the case of same height we can choose the one with the smaller index. So the smaller index is 2, so the answer will be 2 here. For 3 there is no element on the right side and there is no element on the left side, so for this the answer will be -1. So let us see if we have the right answer. So this is the right answer. So you must be wondering will we calculate how we will calculate the left mean and right mean. So this is a standard problem, and this is the problem. We can if you don't know about this problem, then you can go and solve this problem, and then you will be able to solve this problem very easily. So this is the same, we have to calculate the right adjacent element for each element. So this concept will come, we have to calculate the left minimum for each element and the right minimum uh, for each element, and the nearest minimum, nearest min and nearest min in left side and nearest min in right side. So this is the approach. Now let us move to the coding part. We will first initialize the size of the array, and we will slice the stack, and we will calculate left min and right min. and for left twin we will go from left to right, and this is the code for calculating the left mean. And if the size of the stack is greater than 0, we will put left is to the top. Else if there exists no element on the left side which is lesser than ith element, then we will put -1 and we will push the current element. Now we will calculate the right mean, and we will copy this. Now we will go from right to left, and instead of left we will put right, and we will put right here. Now we will calculate our answer. We will find the answer, and if there exist both left and right, and now there exist both left and right of the current element, means for the ith element there exists one element in the left side which is lesser than the ith element, and there exists one element in the right side which is lesser than the ith element. So now we will first check if their height is same. Now if their height is same, then what we can do is we will calculate the left distance and right distance. First let me calculate the left distance and the right distance. Now the left distance is I minus left, and the right distance will be the distance means that the distance between the minimum element and the ith element. So now if the values are same, so if the same height, then we will choose with the smallest index. So if the values are same, we will first check if they are at the same distance or not. So if the left distance is lesser than or equal to right distance, then we will take the left index, else we will take the right index. Okay, now if left distance is lesser than right distance, then what we can do is if the distances are not same, and we have checked that their values are not their values will be not same at this point, and the distances are not same, we will take the minimum distance value, and the minimum distance will be left distance, so we will take the left one. And if the distance of right is lesser than left, then we will pick the right one. Now else if the distances are same, then what we will do is we will check if the distances are same, then we will take the smallest tower. So if the left index value is lesser than equal to right index value, then we will pick the left one, else we will pick the right one. Now if the left and the right one does not exist, if only left exists, then we will pick the left one, else if right one exists, then we will pick the right one, else neither left nor right exists, then we will put -1 in the answer. Now let us run it. We have an error, so it is left min, so we can make this left and right, and sorry, naming convention. So let us submit it. So this is the solution in the C++. Let us move to the Java code. So this is the Java code. I have initialized the size of the length array, and initialize the stack left and right, and this is the code for left minimum, and this is the code for right minimum, and I have initialized the answer. And if left and right both exist, we will calculate the distance from the ith index to the left side and right side, and if the height are same, and if the distance we will take the minimum distance because the height is same. So if the distance of the left side is minimum, we will take the left one, and if the distance of the right side is smaller, then we will take the right one. Now if the size is not same, height is not same, if the left distance is lesser than right distance, we will take the left one, else we will take the right one. If the distance between the ith index from the both side is same, then we will calculate we will check if the left side tower is lesser, the height of the left one is lesser than the height of the right one, and if the left one is smaller than right one, then we will take the left one, else we will take the right one. If left and right both do not exist, then if only left exists, then we will take the left one. If right one exists, we will take the right one, else if neither left exists or nor right exists, we will take the -1, and we will return the answer. Now let us submit it. So this is the answer in Java. Thank you for watching.